Hello everyone, in today's video we are going to cover angles of elevation and depression. After studying today's section, you should be able to apply trig ratios to solve real-world problems. Angles of elevation and depression occur when I have an observer and a line of sight and an object either above or below me. So this is my observer, this is the line of sight. When I look above me, this would create an angle of elevation because again I'm looking up. Now if I'm looking down at the object, this would create an angle of depression because I'm looking down. Now if I look from the viewpoint of the object, so if I have a horizontal line of sight with the object, now both the line of sights would be parallel lines. And then when I look through my viewpoint, this would create a transversal. If I look up from my object, this would create an angle of elevation. Therefore, the angle of depression and the angle of elevation are actually congruent angles because they're alternate interior angles. So the angle of elevation will be the same as the angle of depression. Now looking at our sample problems, first we'll talk about angle of elevation. Remember, angle of elevation problems occur when we look up from our line of sight. So Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? Now it's going to be extremely helpful if you draw diagrams for each one of these problems and then label in our information. So we know that Casey is 6 feet tall, so we'll label this with 6. We know there's a lighthouse that's 84 feet tall, so we'll label this with 84. We know that he is looking up to the top of the lighthouse, and his horizontal line of sight would reach somewhere in the lighthouse. We know the angle of elevation that this creates is 58 degrees, and I want to know how far Casey is from the base of the lighthouse. The base of the lighthouse would be here, therefore I'm looking for the distance Casey is from the lighthouse, so we'll call that x. Now I know Casey is 6 feet tall, so we would subtract 6 feet tall from the total distance of the lighthouse. So the lighthouse, we would use a length of 78. Now I have my triangle here where I have an angle measure of 58. We have the side that's opposite, and then we have the side that's adjacent. So opposite over adjacent is tangent. So I'm going to have tan 58 is going to be equal to 78 over x. I'm going to multiply by x and then divide by tan 58. So x will equal 78 over tan 58. When I plug this into my calculator, I will get x is equal to 48.7 feet. So Casey is 48.7 feet from the lighthouse. Next, jumping number 4, a dog is standing 5 feet from the base of a tree looking up to a cat that has climbed 16 feet up the tree. What is the angle of elevation from the point the dog is standing on the ground? So here we're looking at the angle of elevation, and that's what I want to try and find. So I have a dog. The dog is standing 5 feet from a tree where there is a cat. The dog is 5 feet from the base. We want to know what the angle of elevation is, and the cat has climbed up 16 feet. So now I have my angle. I have the side that's opposite, and I have the side that's adjacent to my angles. So again, this is going to be tan. So tan of x is going to be equal to 16 over 5. To get rid of my tan, I'll use tan inverse. So tan inverse of 16 over 5 is going to be equal to x. And then x is going to equal 72.6 degrees. So the angle of elevation is 72.6 degrees. Now looking at angle of depression problems, remember angle of depression problems occur when I look down to an object, and the angle of depression is congruent to the angle of elevation because they're alternate interior angles. So number 5, a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So if I have the lifeguard on a platform looking down on a swimmer, the angle of depression is 18 degrees. The lifeguard is 8 feet above the water. I want to know how far the lifeguard is from the swimmer, so x. Now I have my angle of depression from this line of sight. Therefore, if I'm looking up from my swimmer to my lifeguard, this would also be 18 degrees. So now I can use 18 degrees, 8, and x. 8 is opposite the 18 degrees. X is adjacent to it, so I'm going to use tan. So tan of 18 is going to be equal to 8 over x. I'm going to multiply by x and divide by tan 18. So I'll get x is equal to 8 over tan 18, which will give me x is equal to 24.6 feet. So the lifeguard and the swimmer are 24.6 feet apart. Lastly, looking at number 7, building A is 480 feet tall and building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart are the buildings? So first let's draw the buildings. So here we have building A, this was 480 feet tall, and then we have building B, which was 654 feet tall. Now I know that looking down from building B from my line of sight, I have an angle of depression of 42 degrees. This would tell me that if I was looking up from building A to building B, this would give me an angle of elevation of 42 degrees. I know that I want to know how far the distance is from building A to building B, so that would be this length here, x. Now I won't use 480 and 654 as both of my heights because I just want to know this length here, because I can see that I've created my right triangle and it's only that distance. That distance is going to be 654 minus 480, which is 174. Now I can use 42, the side that's opposite and the side that's adjacent, which I would use tan. So tan 42 is going to be equal to 174 over x. I'll multiply by x, divide by tan 42. So x is going to be equal to 174 over tan 42. When I plug this into my calculator, I will get x is equal to 193.2 feet. So the buildings are 193.2 feet apart. In today's lesson, we learned the angle of elevation occurs when an observer looks up at an object, while the angle of depression occurs when an observer looks down. These angles are congruent, and you can use either to solve real-life applications involving trig. That's a wrap on today's video. We'll see you in the next one.